Hi, this video is on Module 5, Notes L, rate of change in the difference quotient. And that right there are the two topics we're going to cover, average rate of change and the difference quotient. All right, let's check out average rate of change first. Suppose in 2010 there are 3.2 million users for a particular social media app, and by 2015 there are 5 million users. What is the average rate of change over this time period? So in a lot of real-world scenarios, you're not going to find that the change will be the same every year. It might be a little more one year, a little less another year, and that's what's happening here. So we're looking for, on average, what was the rate of change in the number of users per year. So we want to convert this to users per year. Now, when we say users per year, we're talking about a rate. So we're looking for that average rate of change. So we need to figure out, okay, how many million of users, what was that change, and over what time period? So to figure this out, we're going to do 5 minus 3.2 million users over that 5-year time period. So 2015 minus 2010. This is going to give me 1.8 over 5, which simplifies to 0.36 million users per year. That right there is my average rate of change, 0.36 million users per year. Now, as we completed that problem, I'm hoping that something seemed a little familiar to you. When we talk about, When we talk about the average rate of change, we're talking about that change in dependent variable over that change in independent variable. That change in, whoopsie daisy, go way back. There we go. That change in y over that change in x. That y2 minus y1 over x2 minus x1. That rise over run. What is this the same as? Yeah, you got it, slope. So when we talk about rate of change, we are calculating it the same way that we would calculate slope. So let's check out this next example. Now again, keep in mind, when we talk about average rate of change, we are finding it the same way we find slope, but the change from one increment to the other is not going to be constant. So we're saying, okay, on average, what has happened? Okay, so they give us a graph here, f of x, and they want us to find the average rate of change of f from x equals 1 to x equals 5. Okay, so let's check out those points. From x equals 1, we're looking at the point 1, 0. And from x equals 5, we're looking at the point, put that at the wrong point. When x equals 5, we're looking at the point 5, 1. So we want to figure out, okay, on average, what's the change? Now you can see this change is not consistent. We want to say, okay, well, what's going to happen on average then? Okay, we are looking for that change in y over change in x, that y2 minus y1 over x2 minus x1. So we are going to have an average rate of change of 1 minus 0 over 5 minus 1. So I just treated this as my x2, y2, and my x1, y1. So y2 minus y1 over x2 minus x1, and that leaves me with 1 over 4. 2004. And the directions here say to give your answer as an integer or a reduced fraction. 1/4 is a reduced fraction, so we are good to go. Now, sometimes they'll give us a graph. Sometimes we might see a table or a chart, okay? This table below gives the annual sales in millions of dollars of a product. So it lists out the year and the sales, okay? Determining the average rate of change of sales is important. And this is definitely a topic if you're on the path to business calculus that will come up. It tells whether sales are increasing or decreasing over a time period and at what rate. So if we're looking at this from a business perspective, it's definitely important to know, are your sales increasing? Are they decreasing? Do you need to make adjustments? The first question here wants to know, what is the average rate of change of annual sales between 1998 and 1999? So we're going to go to 1998 and 1999. We're going to see that in 1998 we had 242 sales, and in 1999 we had 278 sales. Okay, so now we need to calculate that average rate of change. We are looking at 278 minus 242 over 1999 minus 1998, so that 1 year time period. So 278 minus 242 gives us 36 over that 1 year, which is 36. So my average rate of change of annual sales is going to be 36 million per year. Not just 36, but 36 million. In the business world, there's a big difference between 36 and 36 million. Make sure you include those units there. What was the average rate of change of annual sales between 1998 and 2004? So let's check out 2004 instead this time. So in 2004, there were 338 million sales. So we are going to have 338 minus 242 over 2004 minus 1998. This is going to give me 16 million per year. Okay, so when we subtract 338 minus 242, we get 96. Let's squeeze this in here. And then 2004 minus 1998 gives us 6 years. And 96 over 6 gives us that 16 million per year. So again, this concept of average rate of change really should be very, very familiar to you. Okay, the same should be true for the difference quotient, because we have seen the difference quotient, although we didn't necessarily call it by that name when we did function composition. Back in function composition, they asked you to find f of x plus h, and then they went on to say, okay, we'll now find f of x plus h minus f of x over h. This right here is our difference quotient. Okay, so let's take some intermediate steps to get there. They say that the function I'm dealing with, f of x, is negative 4x plus 6. The very first thing they want me to do, we're taking small steps here, is find f of x plus h. So everywhere I see an x, I'm going to replace it with an x plus h. This is going to give me negative 4 times x plus h plus 6. So where I saw this x, I replace it with an x plus h. Now that I have f of x plus h, and I have f of x, I'm going to be able to use the difference quotient. Now again, the difference quotient is one of those applications that is going to come up in business calculus. It will also come up in calculus 1 as well. This is combined with limits, gives us our derivative when we get to calculus. We're not there yet. okay? But we're giving you a little sneak peek of what's to come. All right, so let's see what we got here. We have negative 4 times x plus h plus 6. That right there is my f of x plus h. Now I need to subtract off f of x. So I'm going to use parentheses here because I need to subtract off negative 4x plus 6. And I'm going to divide that whole thing by h. So just to make this clear for you guys, this right here is my f of x plus h. This right here is my f of x. And I had to subtract the two. And then I put the whole thing over h. Now, we're not done quite yet because we need to simplify. All right, so let's see what happens when we clean this up. Let's distribute in that numerator. We're going to get a negative 4x minus 4h plus 6 plus 4x minus 6 over h. Here's where the beauty happens. See you later, 4x's. See you later, 6's. We are left with, at this point, negative 4h over h. What happens now? See you later, h's. We are just left with negative 4. So my difference quotient simplifies to negative 4 here. You definitely need to be careful here with plugging in signs, distribution, keeping track of terms, all that. You've got to be very careful on this problem. Okay. Same situation, different function now. We have f of x equals negative 4x squared plus 5x minus 9. We want to find that difference quotient, but they're setting us up with some intermediate steps, and they want us to find f of x plus h first. So, first up, everywhere I see an x, I am going to replace it with x plus h. I am going to have negative 4 times x plus h squared plus 5 times that quantity x plus h minus 9. Now, that right there is f of x plus h, but I'm going to go ahead and simplify this a little bit for us now so that when we plug it into the difference quotient, we've already got it ready to rock and roll, okay? It is very important that you are careful here, and I'm going to do this over here on the side for us, that when you square x plus h, this means x plus h times x plus h. We're going to have to FOIL that out. So we are going to get x squared plus xh plus xh plus h squared. We're going to be able to combine that outer and inner term to give us x squared plus 2xh plus h squared. Okay. A lot of students forget to FOIL that out. You'd be real careful there. So we have at this point, and I'm going to move that equals over because I know I'm going to need the space, negative 4 times x squared plus 2xh plus h squared plus 5 times x plus h minus 9. Now let's go ahead and distribute. We're going to get a negative 4x squared minus 8xh minus 4h squared plus 5x plus 5h, and then we're just going to copy over that minus 9. So that right there is my f of x plus h that I'm going to use in the next step for my difference quotient. All right, let's set it up. First up, f of x plus h. I am copying over what I just found. Negative 4x squared minus 8xh minus 4h squared plus 5x plus 5h minus 9. That is f of x plus h. Now I have to subtract off, and I'm going to use my parentheses, be real careful here, my f of x. Negative 4x squared plus 5x minus 9. And this whole thing ends up over h. All right, let's keep cleaning it up. We can distribute through to that f of x that we subtracted. That's going to leave me with, and right now I'm just copying over these first terms, negative 4x squared minus 8xh minus 4h squared plus 5x plus 5h minus 9. All those were just copied over. Now we're distributing. Plus 4x squared minus 5x plus 9 all over h. Here comes the beauty. See you later, 4x squared. See you later, 5x. See you later, 9. We now have negative 8xh minus 4h squared plus 5h all over h. Check out those terms in the numerator. What do you notice? What do they all have? They all have an h. So we are going to be able to factor that h out in the numerator and get a negative 8x minus 4h plus 5 all over h. Now we can say peace out to those h's, and my final difference quotient is negative 8x minus 4h plus 5. Voila, we have done it. Okay. Good job on that section. Again, just be very careful there. Make sure you're paying close attention to signs and parentheses and all that so that you don't make any silly small algebraic mistakes. If you have any questions, reach out to me. Let me know. I'm more than happy to help. Have a great evening. Bye.